Okay, so welcome back, and may I ask once again if you can to turn your webcam on so that I can see you and I feel a little bit more interactive. Um, Let me present my screen again, and I'm going to try to address a question that came in. There's always, when I'm doing this kind of demos, there's always some detail I'm not telling you because there's too many details to go through otherwise. And there was this great question about where does how does the API know the user email when sending the confirmation email? Because it appears I'm only providing them the token. So let's take a look at that. So the question basically is about this part. When I when I contact the API for my web application and ask it, please send out this email for me. The username and email is in the registration token, but the web API cannot read the registration token. So how does it know the email to use to send out? And I must have sent it some other way. So let's take a look. All right. So let's see. How does the web application call the web API? I think I mentioned that. Hold on a second. I think I mentioned that the am I doing this correctly? Hold on, let me just check something. Yes. So the web application, when it sends out this request, is sending out something called registration data. All right. And I only showed you that this registration data is a hash, which has a verification URL in it, and that verification URL has the token inside of it. Okay. But I think what I omitted here, for the sake of space, because I can't put all of my code into one slide, is there some other stuff in the registration data that I am, in the registration data that I'm sending out. Okay, uh, let's take a look. Um, and let me jump to my code here, and this is my web. This is my web application. So let's go to my services, verify registration. All right, and I'm getting something called registration data, and that's coming in from. Okay, all right. So here, I think I have the answer to the question finally. The answer to the question is that when the user submits this form with the username and email, I am actually sending out the users. I am sending out this full username and email. I'm sending it to the web API, but I'm also sending the web API the registration token. All right. So the web API gets the username, gets the email, and the registration token. It actually doesn't need the username. It only needs the email and the registration token, but I've sent all three out. Maybe I shouldn't. I'm not sure. All right. So does that answer the question? Yes. Okay, great. Thank you so much. It was a very good question. And actually, I was thinking of that question while I was giving the presentation. I was like, nobody will notice. All right. So there's always details I'm hiding or not mentioning. Great. So that was essentially how we do registration. And it's our, for some of you, many of you maybe, it's introduction to token-based authorization. All right. But let's talk about authorization because I haven't really formally introduced this concept of authorization. And actually, what I just did right now with registration tokens, it's not really authorization. It's almost more like authentication to me. All right. So because authorization is more about what are you allowed to do rather than prove who you are to me. Okay. Prove who you are to me is an authentication problem. Let's start talking more about authorization. Right now in my system, users can pretty much do anything they want. I mean, they could go into any URL, see any data they want from any database table. There's nothing preventing a user from saying, "Hey, show me." Sorry to pick on Edgar, but show me Edgar's projects. Hey, I'd like to take a look at this document. Like, there's nothing stopping them from looking at anything as long as they know the correct URL from the API. They can find whatever they want. Okay, so in the coming weeks, since we're now in the authorization module, we would like to control what people can see and also what other things they can do. But for today, I'm going to start with some simple ways to limit what they can see, right? We're going to go into much more details about authorization and formal policies in another week. But today I'd like to give you kind of a glimpse into what authorization is about and what are some of the common problems with authorization. Because when I say, hey, prevent people from seeing certain things, it sounds so easy. It sounds like all I got to do is put some if statements in my code and say, if this project doesn't belong to Edgar, then don't show it to that user. Like, it's so easy. Like, what could possibly go wrong? And I'd like to today have a gentle introduction to authorization and really talk about some of the conceptual problems with why authorization is actually a difficult problem, all right? And why just some if statements doesn't really solve the problem. But I'd like to give you a little bit of theory about authorization to begin with so we understand what this concept is and in some different domains, all right? So bear with me. We're going to leave the code for a while. And even at the end of it, when we come back, we'll solve only one of the authorization problems. There's many other authorization problems that we will not deal with today. We will only approach one problem, okay? So let's start by talking about authorization. This semester, I'm going to talk about a particular type of authorization called discretionary access control. When I say there's one type, there must be another type. The other type, which I'm not going to cover this semester, is called mandatory access control. That is something that is usually more often seen for extremely secure systems like military systems, perhaps financial systems, and also for very low-level systems like your operating system and things like that. So that's mandatory access control. And I won't be talking about this semester. There's some really many famous policies in mandatory access control, but I'm going to stick with what we call discretionary access control. So I just don't have enough time in one semester to cover everything I'd love to cover. Okay, so discretionary access control is basically saying I've got a whole bunch of users and I've got a whole bunch of resources. Which users can do what actions on which resources? Okay, so for example, in the system that I'm showing you in my demo code, we've got accounts. We've got users who are coming in and creating accounts. Okay, so those are the actors. And then we've got projects and files. And who can see which projects, who can see which files is going to be like one authorization problem. All right. Of course, some things may seem obvious to you. Like if I created a project, I should be able to see the project. Sure. But you must want to have collaborators on the project in future, right? Can collaborators see everything in your project or just some things in your project? So these are going to be the kind of questions we'll talk about later. And also in later weeks, we'll talk about who can delete things. Can one of you, just because you have a collaborator, can the collaborator delete files in your project? Or can only you, the owner, delete files in your project? These are all authorization problems, and they're really related to discretionary access control, because essentially we're talking about how certain subjects, maybe they're users, are able to access certain objects, which might be files, projects, whatever your domain is, okay? Um, and I'm saying subjects very loosely because these subjects may not even be human, right? Like maybe there's a bot that's using our system. There's nothing against bots, right? We don't hate robots. But they have to also follow certain authorizations, okay? So generally speaking, when you have any kind of system with multiple subjects, or in our case, users, in some other cases, it could be automated agents, and resources or objects that they can access, then we have to have some kind of discretionary access control, meaning who is allowed to access what. We need to have some rules about like who can access what things, okay? Typically, when we think about this problem, we can think about it in the form of a matrix, where we say that here's a matrix which defines what users can access, let's say in this case, users and files, which users can access certain files. So for example, in this matrix, and this is sometimes called an access control matrix, I've written that file one is a file that user one can read, write, can execute if it's an executable file, and they own the file as well. It's their file. Okay, so I presume they could delete it or they could change the permissions and do other things with it as well. But user one can only read file two and etc. So similarly, the different users have different privileges on the different files. User three, for example, has no privileges on file three, so user three cannot even read file three. Okay, so this is called discretionary access control, and it's often represented conceptually with this kind of a matrix, access control matrix. Okay, all right. Question for you: um, Have you seen any kind of discretionary access like this? Like, does this look familiar? Users, files, read, write, execute, own. Where have you seen this? Anybody? You can raise your hand or write it in the comments. I'll wait a second. Go ahead. Don't be shy. Tell me. Where have you come across potentially this kind of a situation of access control between users and files and things like that? There's something in the chat window. Yenu says Linux system? Question mark. Yeah, the Linux system. Sure. In fact, any operating system has to know which users can access which files, right? And of course, users can share files and they can share folders and they can do all kinds of things. So this is a problem that your computer has to deal with, that your operating system has to deal with, okay? So, so your computer, your operating system must have an access control matrix, at least conceptually. Where is this stored? Where, I mean, is there like a file or like a sector on your disk where an access control matrix is stored? Like, how does your operating system remember who can access which files and do what things? Oh yeah, yeah. So other people are mentioning this is a really good point. With cloud services like Amazon and GCP, there's always all kinds of uh, access control issues. Exactly right. So these similar issues. So in a system, let's take the operating system for now. Where would the user store this stuff, right? Riley's guess is in an access token. Well, you're in the right class for sure, because good guess, because it's the topic of today's discussion. But no, it's not in an access token. And if it was in an access token, sure, it could be in an access token. But where would your computer put it, right? Like, where would your computer store this stuff? Well, there's two possibilities. So let me just talk about the two possibilities. Um, the two possibilities look like this. There's two ways of implementing an ACM. I mean, sure, you could have a big file on your computer with the whole matrix, but that'll be kind of crazy because anytime a user gets created or edited or deleted or a new file gets created, we have to change the matrix will be changed like 100 times a minute. It will be like thousands times a minute or more than that. It'll get really messy to deal with all that information stored in one place. We've got to break it down a little bit and make it a little bit more granular so that we can access parts of this matrix when we want to. So there's a couple of ways of doing it. Option number one, you're going to have a vote soon, as you can see. Option number one, we can create what's called an ACL, ACL, access control list. Here, each file will keep a record of who can access it and what their privileges are. That's option number one. So every time you create a file, the file will have a little access control list saying who can access me. All right. Option number two is a capability list. For each user, we will have like a vector or an array saying which files on this system can this user access and how can they access it. Okay, so let's take a little vote. How many of you think we should use, eeny, meeny, miny, mo, let me just randomly pick one. How many of you feel we should go with a capability list, or a C list as it's sometimes called, where for every user we have a list of all the files that can access? How many of you think your operating system does it like that? Raise your hand. All right, we have some hands raised. Excellent. Okay, great. So 3, 4. Any more bidders? I feel like this is an auction. 4, 4, 4, 4. Only 4? Are you sure? Only 4 of you? 5. 5. Okay. All right. Let's do the other way around. How many of you think that the computer is maintaining ACLs? So for each file, it's got users. Dun, dun. Two people? Three? Come on, 4 plus 3 does not add up to 17 people. Uh, 5, 4? Wow, the class is really evenly divided. Okay. There's only 8 of you who have an opinion, and the other half of the class is like, this question is too risky. I don't dare to. Okay. All right. Okay. All right. So about half of the people who voted went with ACL, the other half went with CList. How can we find out? Well, when you list your directories in Unix or in Mac or whatever you have, you often see something like this, right? Um, this is telling you that this user, this is their privileges to it. So how is the computer actually doing it? As far as I know, the computer is actually using an ACL. It's actually, for each file, it keeps a record of which users can access it, okay? Why not the other way around? Good question. Is there a difference? Like, isn't it the same thing? Like, if I add all the rows of an ACL, excuse me, if I add all the columns of an ACL, isn't it the same as adding all the rows of the C list? Isn't it exactly the same thing? Does it make a difference? It kind of makes a difference on a lot of systems. It depends if you have, it depends which side is changing more. Is your users changing a lot, or are your files changing a lot? Okay. If your files are changing a lot, then potentially it's not a good idea to use capability lists, because every time you add a file, you've got to go through all the users. Like, you may have like 100 users, go through all the users and change the capability lists. Okay. Whereas if it's an ACL, then it's in one place. Then for that file, you can quickly, just quickly update just the ACL for that file. All right. Alternatively, if you're on some kind of a system where users, and by the way, users may not be human, they may be processes, right? They may be like automatic processes. If processes are being born and dying at a high rate, maybe an access control list is not that good, because I got to go find each file and find this ACL and change it. So maybe then I'd prefer a capability list, because then for each user or subject, which could be a process, and let's say those change like 100 times a second, then I just have to kind of like I just manage each process or user's C list. Okay, so that's one thing. It really depends on which one you have more of, subjects or objects, and which one is has more turnover. All right, so that's one kind of consideration. But there's other considerations. So here's a visual picture kind of ACLs and capability lists. So the idea is, with an ACL, again, the objects keep a record of which subjects can access it. With the capability list, the subjects keep a list of which objects they can access and how they can access it. Okay, so this is the difference between again, ACL and capability. This is a visual view. ACLs are probably the most common form of discretionary access. This is the way I think the vast majority of systems essentially keep track of how to do things. All right. Um, but there's a problem with ACLs, and we should talk about it. All right. So security nerds, like maybe me, but even more nerdy security nerds, often like capability lists, because they have a feature that ACLs don't necessarily have. All right. Before I move on, let me ask a quick question. I mean, I'm talking about computer files and stuff. Let's try this a different way. Um, I'm trying to think here. Um, so here's my question for you, and to demonstrate, how things are done. When you enter a building, let's say that you work in a building and you can access rooms only by using like a card. Like, you're an employee, you have a card, you have to scan the card, and then you can enter the specific rooms and also the building. Okay, let's say we have some card-based system to access a building and the rooms inside the building. Here's my question to you. Where do you think, in this kind of a scenario, we store the access control matrix? Like, where is the information of who can access what stored? Is it stored let's say, centrally in the company as an access control matrix, and every time you scan at a door, it has to go through some central server, and the central server has to say, blah, blah, blah. That's one option. The second option is maybe your card contains a capability list saying these are the rooms I can access. Or maybe each door contains an ACL saying these are the people who can get in. How do you think how do you think this is implemented in real life? Let's start with option number one. There's a centralized system, and every time you scan your card, a message is sent to a central server or device or machine, and that central device tells the door you can unlock yourself. How many of you think this is the way it's done? Or maybe this is the way it's done. Okay, cool, interesting. All right, option number two. How many of you think the card should contain which rooms you can go into? Oh, one, two, three, four. Oh, okay, it's a tie. Oh, but we have there's even more. More people feel the card. Third option. How many of you feel it's an ACL? The door knows which cards can access it. Nope. Okay. Hey, some of you are voting twice. I guess that's okay. Very few of you people think the door. Okay. Let me add a little detail, and maybe you can change your mind. Okay, let me add a little detail. Let's say somebody comes to you and says, "Sorry, boss, I lost my card." Now, which system do you wish you had? Centralized system? Okay, actually forget the centralized system. It's too easy to say centralized system. Forget the centralized system. People coming to you and say, "I lost my card." All right. I don't know where it went. I swear maybe I left it in I don't know, I went to the basketball court. I might have left it there. I have no idea where I left my card. Now, what do you wish you had? Do you wish the permissions were at the door as an ACL or as a capability list on the card? How many of you say it should be on the card, given this new scenario? All right, a couple of people. Let me pick on one person. Shichu, can you tell us why you think it should be on the card? But wait a minute. If the permissions is on the card and the card is lost, I can't delete anything on the card. Ah, whoever stole it could show up the next day and get into everything, right? The permissions are on the card. Okay, so I'm not going to ask the other question because I think it's perhaps a little bit safer to, in this case, have it at the door, right? Because if somebody loses the card, you just got to go to the door and like reprogram the door and say, hey, remove this card from each of the doors. It would help to have a centralized system, of course, because then you can sit in one place and just cancel that card, right? But if you had to choose between an ACL and a capability list, then here an ACL would seem better. And this is the reason that ACLs are usually picked over capability lists. Okay, so this is why ACLs are so popular, because if you lose the capability list, oops, can't revoke it. You just gotta wait for them to come back, right? You could do one thing though. I mean, well, yeah, you can't do that, right? So. However, ACLs do have a problem with them, and it's not a technical problem. And we're all technical people, so we're like, yeah, ACL sounds great. There's a human problem with ACLs, and let me try to describe it, okay? The human problem is called the confused deputy problem. And the human problem looks something like this. Eh? I have lost access of, oh, here we go. All right. The human problem looks something like this. Um, in the confused deputy problem, a hacker or an attacker knows that clients or certain people can access their own resources on a storage or facility or something like that, but the attacker can't do that because the attacker doesn't have any credentials, doesn't have any permission to get into a system. So what attackers try to do typically is, when you don't have privileges to any resources, you try to confuse somebody who does have privileges, and you try to get them to bring the resource to you, since you cannot get it yourself. All right. So this is the general idea of a confused deputy problem. There is somebody with access, and you need to confuse that somebody into giving that into accessing those resources and giving it to you. Okay. Preferably, like for example, if this attacker wants the files that belong to this client who's in blue, so these two blue resources, we need to find a deputy, and a deputy, they're called a deputy because a deputy is somebody who you authorize to do something. All right. So essentially, you confuse somebody who has access to this client's resources. Maybe this person has access to all the resources, and you try to fool them into giving information about this client to you. Let me try to give you a a couple of real world examples. All right. One real world example is this. So imagine you're a student and you suddenly realize, not you come out of the exam room and you realize, oh my God, I failed this exam. I need to, and you can't do, you submitted the exam, you realize later your friends tell you, oh, you got it wrong. And you're a really bad person, none of you, but you're a really bad person, okay, Eve, and you decide, I need to get my exam back from the professor before the professor grades it because I need to fix everything that I did wrong. Okay. However, the exam is in the professor's office. All right. And you're like, shit, the professor's office is locked. I can't access the professor's office and steal my exam back. And now the professor is going to grade it tomorrow. So tonight I need to get into the office and I need to get that exam back and either fix it or tear it up or do something. How are you going to access it? Because you don't have a key to get in, right? What you could do, and I hope none of you ever do anything as foolish as this, is you could try to confuse somebody. Well, you can't confuse the professor because that'll be too difficult. You can't come to me and say, hey, Soumya, could I borrow your keys for a day? Oh, I'll give it back to you tomorrow. I'm not going to give you my keys, okay? It's not going to work like that. So what you need to do is to convince somebody else who has access to my office to get the exam for you. How to do that? Well, who has access to my office other than me? Well, a lot of people, in fact. My department has access to my office. My department administrator has access to my office. You know who often also has access not only to offices, not only to one or two offices, but to every office and every room in every building? It's our good friend, the janitor. The janitor is the person who cleans the building. They usually have keys to everything, right? If you ever see them walking around, they have like 1,000 keys on them. All right. So what you could do is you could approach the janitor and say, hey, listen, I need you to do me a favor. I need you to go to Soumya's office and open the office and like get me a file from the office. Okay. Of course, the janitor will say, no, are you out of your mind? I'm not going to do that. So what do? Well, you have to confuse the person into doing it. Here's the thing. You don't necessarily have to ask the janitor to do something weird, like, can you please access the office? The janitor has to clean the office eventually anyway. So you can just tell the janitor, listen, I'm not asking you to open the office for me. I'm just saying, when you're cleaning the office, could you get that file for me? Now, why would the janitor do it? Well, maybe you look a little bit like me. I don't know. Maybe you wear glasses. Who? Steven? Maybe Steven. Maybe Steven could pull this off. Steven could say, hey, I kind of look like Soumya. Could you please, I'm Soumya. Could you please access, it's my office. I forgot my keys. I don't even need access to the office. I'm just going to wait down here. Hey, when you're done cleaning it, just grab the top, just grab these assignments, just grab me the whole assignments and bring it down here for me. Would you do that? And maybe the janitor could be fooled. And if you go, sounds very authoritative. I better do this. I don't want to get in trouble with the professor. Okay. So this is a confused deputy. Why? Because you have abused the privileges of somebody who has a lot of privileges. All right. And you're confusing them into doing something that you or yourself are not allowed to do or would not be allowed to do. Just because they have the ability to do it, you are abusing their ability. All right. This is the confused deputy problem. One of the most famous hacks in the early days of the internet, nowadays, my God, hacking has become a science a branch of science practically. But one of the most famous hackers back in the early days, let's see, what was his name? His name was Kevin Mitnick. Anybody heard of Kevin Mitnick? Raise your hand. All right. So Kevin Mitnick is a old school hacker from long time ago. In fact, he's considered one of the first early malicious hackers, like the most famous ones. And he became famous because at a very early age, I think while he was a teenager, like the FBI came and arrested him for breaking into like some different companies. And this was a long time ago. I think that was back in 1995 is when he became famous. So I was a computer science student at the time. You can kind of guess my age now. But I was a computer science student at the time, so he was like our hero. I was like, whoa, what a cool dude. He's breaking and hacking into all kinds of companies. And a lot of the movies that came out in the 1990s were kind of based loosely around stories about Kevin Mitnick. And Kevin Mitnick was really interesting because he was one of the first and early serious hackers to get in big trouble. He was kind of arrested by the FBI, charged with wire fraud. In fact, his even after he got out of prison, the courts put a rule on him that he cannot touch a computer or forget the internet. He cannot touch a computer for a certain number of years. So he was not even allowed to even touch an electronic device because they were that afraid of him. Okay. But the interesting thing about Kevin Mitnick is, yeah, sure, he knew some intelligent technical hacks. But what he was especially good at, and he writes about this a lot, is he was actually a master at social engineering. He knew how to hack people, not how to hack machines, and he could get into anything that way. And one of his most famous hacks, and I'm kind of recalling this, so forgive me if my details are a little bit off, went something like this. He needed to access a server, and he couldn't access the server. He needed to break into this company. Why he needed to, I don't know. But so this is what he did. He didn't even know where the server is. He doesn't even know the IP address of the server. He doesn't even know what to do. So what he did is he tried to access the system through some web portal or some kind of public way. And he did something very suspicious. I don't remember what it is, but he did some behavior, maybe try to log in 3 or 4 or 5 times. He did something that looks suspicious. And then he left the system. And then he called the customer support of the company. And he told the customer support, hi, I'm the security agency. I'm hired by this company and I'm its security consultants. And I just got a notification that somebody's trying to hack into your systems. And the customer support is like, what? Into my systems? They said, yeah, be careful. Somebody's trying to hack into your systems. And in fact, I can tell you what they're trying to do. They're trying to, and then he described what he was doing 5 minutes before. He said they're trying to use this username and this and that, and like this is they're trying to hack in. And the customer service agent was very impressed, like, wow, you know all this stuff. Wow, you're amazing. And he said, yeah, I'm the security consultant. I need to know these things, right? And then he said, okay, I'm gonna solve it. So I'll fix it. Don't worry, but just keep an eye for any other suspicious activity. I just need one thing. Can you just tell me the URL? Can you just tell me the IP address of the server that was attacked? And then the customer service agent said, yeah, of course, here's the IP address. And now he's got the IP address. Okay. How did he get it? He confused a deputy. He confused somebody who has access to this information. All right. So this is an example of social engineering, of a social engineering attack. All right. And in general, this is called a confused deputy attack because you're confusing somebody else to do something that they have the authority to do, but you don't have the authority to do. All you got to convince them is that even though you don't have the authority to do it, that somehow they must do it for you. All right. So one way of preventing this confused deputy problem is to use this technique that very few people actually use nowadays, which is called a capability list. All right. And how does a capability list help? Excuse me. With a capability list, what you do is this. You instruct all your personnel, maybe it's customer service, maybe it's the janitor, maybe whoever it is, you instruct all your personnel that, listen, if anybody comes to you and asks you to do something, um, don't say no. I mean, maybe it's a professor or a doctor or somebody important, like you need to help people, but say, yes, I will help you. But tell them, give me your C list. Give me your capability list. Maybe it's a card, maybe it's a token, maybe it's something else. You ask them, give me your capability list, and I'll do whatever you want me to do, but I will use your capability list, not mine. All right. So the idea of the capability list again is that what resources a subject can access is stored in this list, which could be on a card or a device. And you tell the janitor or the customer service or whoever it is, if anybody asks you to access resources, tell them, yes, I will do it for you, but with your capability list. Give it to me. Give me, like, so if I'm in the basement and I tell this janitor, hey, I need to access my office, the janitor will say, no problem. Give me your card and I will access whatever room you want me to access. But if you cannot give me a card, I can't access anything for you. And if you give me a card that cannot access certain resources, then I can't access it for you. So the one way around the confused deputy problem is to tell anybody who could be a deputy to get a C list from the person or the attacker or whoever is asking, and to provide and to use their capability list instead of using your own privileges. Okay, so this is the general idea of a capability list, and the general notion of why it's gotten a lot of more attention in the past few decades, even though it has many drawbacks that ACLs don't have. Like we mentioned, if you lose a capability list, anyone can access your resources, right? We'll try to see how to get around that in a moment. But at least one good thing about a capability list is you can give somebody else your capability list, and it's safe for them to act on your behalf. And you can't really do that easily with an ACL, with an access control list. Okay, so let me go ahead. So this is the idea of capability lists. All right, so this is the end of the theory section of access control, and let me talk about how we're going to actually implement access control authorization. One of the ways in which we're going to deal with authorization today. Okay, so but I'll wait. I'll take a 30-second break to see if there's any questions, and also drink some water. All right. So let's talk about how we're going to do it this semester in this class. Okay. So the idea is going to be something like this. We're going to create something that looks a lot like a capability list. It is not exactly a capability list, but we're going to treat it like a capability list. And it's going to be another type of token. We've talked about registration tokens. I'm going to introduce a new type of token called an authorization token, or an auth token. All right. And the way auth tokens work is as follows. Okay. I'm going to describe two processes in which auth tokens are going to be used. One is a login process, and the other is any process where somebody wants to access a resource, like give me a project, give me a file, etc. Okay, so let's talk about the login process. So this is all about distributing trust. Remember, in our system, we cannot trust anybody in our system. Like the API, as of today, cannot trust the web application. It doesn't know who's making requests to it. Anybody can make a request to the API. The web application can't trust the browser yet. It doesn't even know whose browser it is. All right. The only person we can trust, the ultimate source of our trust, is the user. Okay, that's who we trust. So the way we're going to do it is as follows. When the user logs in, they have to provide a username and password. All right. The username and password is sent through the browser to the web application. The web application, and I'm calling this username and password, I'm just calling it credentials. The web application passes the credentials onto the web API as part of the login process, because it's the web API that needs to, I forgot to draw the database, that needs to access the database and say, hey, is this the right username and password? Okay. So the web API checks that the credentials are correct. If the credentials are correct, then the web API knows that, listen, I don't trust the web application, but somehow the web application has the credentials of the user, and I do trust the user. So for now, I'm going to trust the user, and I'm going to trust the web application because the web application was able to present to me something that the user is and something that only the user knows, username, password. Okay? So because this web application seems to have access to this information, the user must have somehow indirectly trusted the web application. So I will trust the web application. And here's what I'm going to do to show my trust. I'm going to, since I've got the username and password, I'm going to send back to the web application the account information of the person whose credentials that I just got. But I'm also going to pass back one more thing. I'm going to pass a token. Once again, the token is just a encrypted information of some kind. But this time, it's created by the web API, not by the web application. It's created by the web API. So only the web API can read the token. Okay? And so the API sends the token back to the web application. And you know what? The web application can do whatever it wants with the token. But it needs to somehow store it somewhere. For example, in our case of a web application, it will do two things. It will store the token in a session store, okay, like our Redis database or something. And it will pass back a session ID to the user as a cookie. And if the user comes back, the web application can look up that auth token again if needed. Okay. That's our web application. If it's a mobile app, it'll be different. If a mobile app does not necessarily need to use Redis or something else. A mobile app can just store it locally on the mobile device itself. All right. So a mobile app would have its own strategy to store the auth token. But and that's the end of the login process. Now we're getting to the and that's still authentication. Now we're getting to the authorization process. When somebody asks the API, hey, I need a resource, all right? The API doesn't need to care who's asking it. It doesn't care, are you a web application? Are you like some curl or wget request from the terminal? Are you a mobile app? Are you another computer, or are you a person? It doesn't care who's asking it for the resource. All it says is, fine, I will get you the resource. Give me the authorization token that I created. All right. If you can show me the authorization token, then I know that sometime in the past I trusted you. And because you can show me evidence of this trust, I will trust you again and give you this resource. All right? So this is essentially what a token is. A token is a symbol of trust, and it says, I trust you, bring this back to me, and I'll know to trust you again. Even, I don't care who your identity is. I don't care who you are. If you can give me the token, I will trust you to give this back to me. All right? This is the basic idea of an authorization token. All right? I'm going to get into a lot more details, but this is the overall big picture view. All right? And I'm going to use tokens in a couple of interesting ways in the next 2 to 3 weeks. But this is the high level view. All right. let's try to change one resource on my service so that I can demonstrate one use of this token, a simple use of this token, but an interesting use of the token nonetheless. Okay. Any questions? I'll just wait. I'll just take a little break here again to wait for questions. Yeah, please unmute yourself and go ahead. I cannot hear you. Let me, Rona, go ahead. No, not Rona. Who is this? Uh, can you unmute yourself and ask your question? I cannot hear anything. So, oh, maybe it's in the chat window. Yes. Is the auth token the basis of OAuth? Ah, you're asking me a question that I'm going to cover next week or the week after. Yeah, no problem. So you're asking me about OAuth, which is an authorization protocol, which I'm going to cover in a following week. So I don't want to give the answer away today. I'm so sorry. Otherwise, you won't come back in the future. I got to get my customers back. Okay. So please wait for me for a week or two, and I'll discuss OAuth. Okay. Thank you for the question. Cool. All right. Let me go back to the presentation. All right. So this is this is again the idea of an auth token. And let's see how we're going to use it in today's class. Okay. All right. So I'm going to, first of all, start working on my API. My API has to develop this auth token. So let me first show you, before I show you a demonstration of how to use it, let me first show you how to make the auth token, okay? Now, as you can imagine, because you already saw how I made the registration token in the application, you can imagine that I'm basically going to take some important information and I'm going to encrypt it. And that's going to be an authorization token, okay? Now, in the application, in the web application for the registration token, I just reused the secure message library of my web application. In the web API, I don't have a secure message library. I do have a secure DB library. Remember, like a while back, we made a secure DB library that does cryptographic stuff, but it's for the database. Today, I would like to create a new library just for authorization tokens. However, it's going to copy a lot of code from my secure DB because it does a lot of the same stuff. It needs to use RBNSCL to do encryption and decryption and so on and so forth, okay? So it's going to have a lot of overlapping code with my secure DB. So what I'm going to do today is this. I'm going to, little preview, I'm going to eventually need a little library that creates auth tokens for me. It's going to have a lot of similar code to my secure DB library that's already in my API. So what I'm going to do is this. I'm going to create a new kind of a module called Securable. And this module will take care of everything related to RBNSCL and encryption and cryptography. Okay? I'm going to remove all the cryptographic code from SecureDB and instead ask SecureDB to include this module so that it can do cryptographic stuff. And I'm going to reuse this module and include it in auth token. Okay. Notice I'm saying I'm going to include it. I'm not going to inherit it. I'm not going to use inheritance. In object orientation, I'll discuss, I usually talk about this in my other class in SOA, but in object orientation, inheritance is really overused and we hardly really need it for a lot of the things we think we need it for. If we just want to reuse the same functions and code between two classes, we can use composition, which is basically where you create some functions in a module and you just include the module into whichever other classes need it, okay? So that's what we're going to use. So here I am. I'm going to create a module this week called Securable. And it can do all the stuff that SecureDB did last 2 or 3 weeks ago. It can generate a new key if it needs to. It needs to be set up. You need to provide it a base. You need to provide it an encryption key, okay? And if you provided the encryption key, then it can encrypt and it can decrypt stuff. Okay, there might be some stuff I'm missing here, but this is the general idea of the securable module. Okay, I think I'm missing some stuff here, so let me just kind of go to my API and find the securable library. Where is my library securable? Oh yeah, I forgot the key. The key method, which actually gets the key, decodes the key and gets the raw binary key back. Okay, that's the only function I'm missing in that. Okay, Edgar, please remind me. Okay, cool. All right, so now that I've made the securable module, all this cryptographic code, I can remove it from SecureDB. My SecureDB for this week's class, which I made SecureDB a couple of weeks ago, but this week I can shrink it down incredibly. I can just say this extends securable. Notice I'm not using the word include, I'm using the word extend. There's a slight difference. When you include a module, all the functions of that module become object level methods or instance level methods of the objects of that class. When you extend a module, all the functions of the module you're extending become class level methods. Okay, so that's the difference between include and extend in Ruby. All right, so I'm extending securable, so all these functions become class level methods of SecureDB. And now all I have to do is create an encrypt and decrypt method for SecureDB. I just have to change it a little bit, remove all the cryptographic stuff, and just call base encrypt and base decrypt. Base encrypt and base decrypt from the securable module. Okay, SecureDB is now a super small, simple class now. All right. The only thing it's doing more than encryption is just it's doing the base 64 encoding and decoding that I need. All right, so that's SecureDB. I can forget about SecureDB. All right, but since SecureDB is now extends securable, I do need to do one thing in environments.rb. I've got to set it up and provide it the database key. All right. The class I want to talk about today is auth token, and auth token also extends securable. It's going to have the same cryptographic underlying functions as SecureDB. All right, so I'm just kind of refactoring the code a little bit this week. So here is auth token. Auth token is another library. It extends securable. All right, and it does a couple of interesting things. First of all, you can by the way, the code for auth token, it's like all this stuff and then all this stuff on the right-hand side. So the code kind of goes top to bottom until here, and then it goes to the top over here, and this is also all auth token code. Okay, so let's go through it a little bit to see what auth token does. Auth token essentially, or let's see how to use it. If you want to create an auth token, here's what you do. And this is not related to my project. I'm giving a generic example. Let's say I have a hash with 2 keys and they have 2 different values. I can create an auth token out of it by simply saying token is equal to auth token.create and then the data that I want to create the token out of. Okay, so .create is the keyword. Here's something else I can do. I can create an auth token just like I did before, but this time I can give create an extra parameter telling it this token expires after 1 month. Interesting. So I can create a token that is not valid for more than 1 month from right now, from the moment I created it. Okay. And then later on, if I have a token which has already expired, in this case, I'm creating a dead token by just making a token with a 0-second expiration date, means it was created and expires at the same time. Then, if I try to ask the auth token library to give me the payload means the data within dead token, it will raise an exception saying expired token error. All right. Or if I try to get a token, which, and here I'm passing in not a real token, I'm passing in a string, which is just some random characters I entered, which happens to read like fake token, then auth token will tell me this is not a valid token even. Forget expiration, it's not even a token, all right? So auth token, this auth token that I'm creating, library, it can do two things. You can give it a token and it can give you the data that's in the token. It can basically decrypt the token for you, but it can check to see if the token has either expired or if the token has either been tampered with or if it's not even a real token, in which case it'll raise an exception saying invalid token. All right, so that's auth token. How does it do its magic? Let's look at the code. When I ask for the payload means what is the content of the token? What was the encrypted information? What was the information that got encrypted into this token? I call this detokenize class. All right. In detokenize, I essentially just I decode and decrypt this token. All right. And if I cannot decrypt it because somebody has tampered it, remember I'm using RBNSC as simple box, so it's got like a MAC authentication code built into it, right? So if it's been tampered with, if somebody has edited, changed, or given me just rubbish data, then it will raise this invalid token error. All right. So if somebody tries to get the payload for a fake token or an edit or a modified token, they're going to get this invalid token error. Okay. Now, if I manage to decrypt the token, the next thing I do is before I return the actual content of the token, I check the expiration date. So where's the expiration date? Let's look again closely at how the token is made. When you create a token, you give me what's called a payload. You give me the data that you want to be put into the token. What do? I create a Ruby hash, and I put your payload into the keyword payload. And then I create an expiration date with the expiration date that you specify. The default is 1 week. All right. Expires is basically just a function that takes the current time, adds the expiration time, and converts it into an integer. All right. So basically creates a time in the future in computer format in terms of seconds. All right. So the contents of this token is going to be the data payload, the actual content, and an encryption date. Now, what I can do is I can when you give me the payload, when you give me the token, I can try to detokenize it, and then what I do is I check if it's already expired. I've got a function here called expired, and all it does is it looks at the expiration date in the contents of the token, and if the expiration date is more than now, it's like after right now, then excuse me, if the expiration date is before right now, meaning the current time is greater than the expiration date, then I raise invalid token error. Okay. Otherwise, I return the actual payload of the token. All right. So an auth token is just like our registration token, but it has one more thing. It has an expiration date built into it. Riley, you earlier asked the question, does the registration token expire? No, it doesn't expire. Do you want it to expire? You can create something like this. You can modify the registration token to do exactly what I'm doing here. Okay. And then you can have an expiration date associated with it. All right, moving on. Right. By the way, note, you will need to do two things. You will need to create a message key, and the auth token will use this message key. And you need to kind of set up your auth token in your environments.rb with this message key. Let me read the comments for a second, and I'll take a little break here. All right, great. So how do we use auth token? So let's go through the two processes I talked about before, the login process, the login process, and the resource request process. Let's go through these processes step by step to see how auth tokens are created, stored, how they're used to access resources in a simple way. We will use it in a more complex way later on. All right. So let's talk about, where are we? Here. Let's talk about the login and authentication process. When a user comes in and they log in with my web application, they provide a username and password, and my web application passes that username and password onto the web API. In particular, it passes it to my API v1 auth authenticate route. That's where credentials, username and passwords are sent to verify that they are correct. All right. So what I'm doing is I'm getting those credentials from the body of the post request. And then in my API, I'm calling a service object called authenticate account. An authenticate account looks like this. It starts by trying to find the account with that username, and then it tries to verify that the password is correct, just like we did last week. All right. So all this code is from last week. Last week, when we finished doing this, or last 2 weeks, when we finished doing this, we just returned this account object, username and email. All right. But this week, I'm going to do something else. This week, I'm going to say, please convert this account into an account and token. And here's a method to create an account and token. So it's, I'm basically, the attributes are going to be two things. One is the account information, and the other is an auth token created by the auth token library with the account information, username and email. All right. So I'm returning. So when somebody is logged in, well, the API doesn't know they're logged in. This is just a authenticate route. When somebody authenticates a username and password, after I've made sure it's the right username and password, I send back the email and username, the account information. But I also send back an auth token, which is the same account information encrypted and the expiration date. Remember, only this web API can ever decrypt this auth token again. Nobody else in my system can look into this auth token because it's encrypted, right? So now, let's see what the web application does once it gets back this combination of account and auth token, all right? Now, in my web application, I've also done a lot of refactoring here, so please bear with me. I've created two new classes called current session and current account. They're now under the models folder of my application. My application didn't have any models till today, because usually when we say models, most of us think about database models. We didn't have a database, so I didn't have models. But that's not what really models means. Models just means any interesting business logic, any interesting logic is called a model, all right? So I'm gonna have some logic about how to handle accounts and how to handle sessions, all right? So I've created these new two classes to help me deal with accounts and sessions. The accounts model is very simple. You give me account information and an auth token. And what I simply do with this, I don't do anything with the auth token because I can't read the auth token on the web application. I just hold on to it. But with the account information, username and email, I provide a couple of helper methods that just extracts the username and email from that hash. Okay. Also, I can check to see if there is no account information yet. I just then it tells me the user is not logged in. All right. The current session object, this is actually a wrapper around the secure session that I created last week. Secure session is great, but it's a little too low level. So I've created this new class called current session. And what it does is it stores the current account information into the secure session and gets it back, and also gets the token back as and when necessary. All right. So the current session can basically look up the account information from the session store. It might be Redis, it might be cookies, wherever you're storing it. And it can create a new current account out of it. All right. And it can also delete a current account from the session. You can basically invalidate the session. All right. So let's talk about the process here. Oof, let's stretch out a little bit because this is a little tiring to explain. All right. It's really tiring to talk online because I can't see faces in front of me, and it's like I feel like I'm just talking to the wall. It gets pretty boring after a while. That's why I ask for the webcams. So at least I can see you smile and go, oh yes, or confused. I need some kind of feedback. I'm human. All right. All right. So I'm just gonna take a little bit of a second break. If you have any questions, you can raise your hand now or type it. All right. Let's get going. So let's talk about this login process. When somebody logs in and let's go here. Oh, what am I doing here? Kevin Mitnick. I don't know why new things are popping up. That's not good. All right. Welcome to Credence. Oh yeah, I was logged in as Somya. Let me log out. And when I log in, so Somya, actually, let me log in as somya.ray because this account actually has some projects inside of it. So I'm logged in now, and I can go look at my projects in a moment. But let me just talk about this login procedure again because I've changed it a little bit this week. So when I entered my username and password and I hit login, that form got posted to auth/login. And what auth login is, first it tries to authenticate the account with the username and password. What this basically does is it sends a message to the API saying, is this the right username and password? The API will send back as the account information and the auth token, right? So then what I do is I take from the account information that comes back, I take the account information and the auth token, and I create a new current account, all right? That's just a library that helps me access what's inside the account. It doesn't do anything with the token, just stores the token, right? And then in this using current session, I say, please make the current account equal to this current account that I just got. All right? And that securely stores both the account information and the token into whatever my session store is. It might be Redis, it might be Pool, it might be Cookie, wherever, but like store it somewhere. All right. And then I say, welcome back, user. Now, on every request, including after I logged in, I came back to the home page, right? Now, for every request that comes in, including redirecting me to the home page, like right down here, I redirect the user to the home page, right? Once they've logged in. When they're redirected to the home page, at the very top of my controllers on app.rb, the very first thing I do, well, I think almost the very first thing, let me go to my API, and let me try to find controllers, app.rb. One of the very first things I do, I've changed the code a little bit. Oh, this is the API. Sorry, I should talk about the web application. Okay, so my web application, yeah, the first thing I do is I always set that my content type will be HTML because it's a web application. Okay, but the second thing I do, but the first substantive thing I do is anytime someone makes a request to the web application, I look at the current session object and try to retrieve the current account, which includes account information, username and email, and the auth token. I try to get those both back. And that is my current account object. Okay. And then I do things like I go to the home page. All right. Because I'm now passing in a current account object, my homepage, for example, can do really cool things like, let's go to my homepage. I can just say current account.logged in. That's really nice to read. I just got a little function in current account saying, is the user logged in? Basically, if I have any current, information about the user, then they're logged in. All right. So the first thing I do with every request to my web application is I try to see if the user's account information and auth token is in the session store, and I get that back as a current account object, which has, remember, the current account object has really user helpful functions like username, email, logged in, and logged out. All right. By the way, when I log out, I will tell the secure session to delete this account. Now, let's go to the second process that I was talking about. So we've talked about login, what happens, okay? What happens when people request actual resources? I'm going to just show you one example because it's the simplest one. And then next week, I'll show you more complicated examples of trying to access resources, okay? Not next week, but in the next 2 weeks sometime. So when somebody tries to access a resource, for example, if somebody says, show me all the projects that belong to SOMI array, okay? I'll show you something interesting here. I'm going to click on projects, and okay, I've got one project. I can't click on the project because I actually haven't created the project details page yet, but this project would show if I have 2 or 3 or more projects, it would list them all here, all right? Notice the URL, it's /projects. It doesn't have my username in there. It's just /projects. Interesting, huh? Like the URL is not /user/SOMI array/projects. It's just /projects. All right. So think about that for a moment. The username is not in the URL. Okay. So what's going on when I ask to see the projects? Well, my web app needs to now reach out to my API and ask it to return the projects. I'll talk about what the API does later. But this week, I'm changing how I'm requesting resources. This particular resource, I'm changing how I access this particular resource, which is the project listing from the API. Essentially, I want to get the API to return to me all the projects for this user, but only if I'm allowed to see the projects for this user. And let me show you how I'm doing that. It's a little implicit. It's not really visible in the code so much. So my web app will ask the web API when I click on the projects link, right? I'm doing a GET request in my web application. I'm doing a GET request on /projects. So what I first do is I check, is the user logged in? Then I do this. Otherwise, I just redirect them to a login page, first of all, okay? You want to get the projects? Well, you better be logged in. If you're not logged in, you're not going to see those projects. So if the user is logged in, then I call the service object called getAllProjects. The service object is the one that actually talks to the web API. All right. And it returns a projects list, which I then display on the screen. But how do I call this API, and how do I inform the API that I want the projects for this particular user? Remember, the API doesn't, from this week, the API doesn't really trust people anymore. So when I say I want all the projects of a user, the API is going to say, why should I give it to you? Who are you? Why are you asking for all these projects? So this is how I prove to the API that I'm allowed to see the projects of the user. All right. I make an HTTP GET request because I want to get a list of projects to the API's URL. So that's Credence API, herokuapp.com /API v1 /projects. Interesting. In the URL, I am not telling the API whose projects I want. I'm just saying, I'm telling the API, I want to see all the projects, but I'm not saying which user yet. Kind of crazy. Instead, what I'm doing is I'm passing back an authorization header. All right. So when I make this, oops, this should be a GET request. Edgar, this should be a GET request to the API for all the projects. And I'm going to now authenticate myself in a way, or I should say, I will tell the API I'm authorized to get these projects. How will I do it? I'm going to use a different type of authorization, not the basic authorization you saw earlier with Mailgun, where you literally pass the username and password crazy. I'm going to use a different type of authorization called bearer authorization. In English, the word bear, of course, is like shong, it's the animal, but it has another meaning as well. The word bear also means to carry something. Like if you're bearing water, it means you're carrying some water with you. Or so bear in English also means to carry something. Bearer means I'm carrying something that you might be interested in. What am I carrying? So in the authorization header, I say I am the bearer of a token. So when I make this GET request for all the projects from the API, I set the authorization header and I say I am the bearer, and here I am passing back just the auth token. Only the auth token, not the account information even, just the auth token, which the application cannot read. All right. So this is really cool. I'm asking the API for all the projects of a user, but I'm not telling the API which user I want the projects for, because I will let the API figure it out from the auth token. Right? Think about this. I am not telling the API what I want. I'm proving to it what I can get. That is, in spirit, it's similar to a capability list. All right, where I am saying, I need some resources from you. Here's my capability. And I give it to the API. Now the API will go look through all the projects, and it will only return the projects that matches my auth token, that matches the username in the auth token, right? So this is really cool. If somebody intercepts this HTTP request, well, they can't read the auth token, and the URL doesn't even tell them which user I'm trying to get information on. That's great. To me, the best type of security is when your data is not even visible, right? So I'm not even telling it which user I want. I'm just passing it an auth token. So I call this the prove, don't tell principle, meaning the application does not tell the API who the user is. Instead, it uses the authorization token to prove what projects they can access, right? And now the web API should return to me all the projects that belong to the user with this token, right? Or at least all the projects, I shouldn't say belong to, all the projects that the user with this token can access. It may be projects that are shared with them. We'll talk about sharing and other privileges later on, all right? How does my API do it? Well, let's look at my API. My API gets this request. Please send me all the projects. For who? I'm not telling you who, but here's a token. Here's an auth token. So what my API does is, this is, in the routing of the API, at the top of the routing in app.rb, before the routing even begins, the first thing it does is it looks for a token. All right. It looks for a token using this authenticated token method. I've created this function called authenticated token. So API, excuse me. So cancel. Excuse me. So this week in my API, I have in app, I start by saying, please the routing, one of the first things I do in the routing is I'm checking for HTTPS and stuff like that. But the next thing I do is I say, is there a token? Get it for me. Okay, and I'm using this function called authenticated token. This function is available in a module in a file in my controllers directory called helpers. Helpers will contain methods that could be helpful for me, and essentially I'm just including those helpers into my controller, into my app, Rhoda application. Okay, so authenticated token, what does it do? Authenticated token, essentially, it looks at your headers of the HTTP request. It looks particularly for the authorization header of the HTTP request. It extracts from the authorization header the part that matches bearer something something, and that something something is going to be the token. Okay, so it gets this out of the so it actually recreates the token from the payload that comes from the authorization header. All right. Okay. Next, what next? Now, when the routing goes to API v1 projects to get all the projects, but I haven't even told it whose projects yet. No problem. What I'm doing now is at the beginning of my controller, whichever token I got in the whatever request it was is now stored in auth token. I now open up auth token. It's called auth account. This is the decrypted auth token. I look at the decrypted username, and in my route for API v1 projects, I simply say, find me the account that matches the account that was in the auth token, and give me all the projects that belong to that account, and return it, and then it returns this back to the web application. Okay. Okay. So this is the essential idea now. So going back to the picture I had earlier, anybody who wants to get a resource like all the projects, no problem. I'll give you whatever you want. I don't even need to know who you are. Just give me the token, and I will give you whatever your token allows me to give you. All right. So this week, I would like you to pick some resources which don't need too much logic, like give me all my projects, give me all my files, give me all this, give me all that. So just any resource like that, just use this technique of, instead of asking who the user is, just like, for example, let's say your project is dealing with secret documents. Then when the application asks the API for the documents of a user, don't tell them which user. Don't tell the API like user and the username. Just say /documents and pass in the auth token, and let the API figure out what it's allowed to send back. Okay. So you don't need to authorize all the paths this week, but whichever paths you can authorize without too much logic, like you just need to return a list of stuff, then that's all you need to do. All right. Cool. Okay. That's all I want to say about authorization tokens. I have one more little thing, but this essentially kind of covers this idea of how do we distribute trust and how do we use authorization tokens. It's a similar idea to registration tokens, but this actually contains something more like a capability list inside of it. It contains the identity of the person who is allowed to open things. All right. Any questions on what I've shown you so far? We've got 10 minutes. I have one more thing to show you, but I'll wait on that until. All right. Okay. The last slide I had here was on testing. if you are testing your API, then this, which you should be, because by the way, I am going to grade how well you have tested your API. I am going to be a little flexible on how much you test your web application because your web application is browser based. It's hard to test the user experience. You can test the service objects of the web application, maybe at most. But what I'm going to test is, excuse me, I'm going to see how well you've tested your API. So you've got to change your tests this week for any routes that require authentication, authorization, not authentication, for routes that require authorization. So for example, I have a happy test here, making sure that I can get the list of all projects. So these are the getting projects tests, and I should be able to get all the projects for an authorized account. How do I do that? What I need to do is I need to first authenticate an account with the username and passwords, and this auth object will contain a token in it. And when I make the request now as part of my test to get all the projects, I need to pass in the header, authorization, bearer, and the auth token. Okay, so just reuse the authenticate account service object of the API, which gives you an auth token, and use that auth token in making your request for authorized routes. All right, so that's the thing I wanted to mention. You should also include some bad tests this week where you're trying to get resources like give me all the projects, but you're passing in not a real token, a damaged token, or a bad token, something that is not a token, okay? And that should give you a 403 error code. 403 just means unauthorized, all right? Is that what 403 means? Let me just double check. HTTP statuses.com 403. Oh, 403 means forbidden, not unauthorized. There's a difference. 401 is unauthorized, and usually 401 means it lacks valid authentication credentials. All right. But 403 means I understand what you're asking for, but I cannot give it to you. And it's not because your authentication is wrong. So to me, 401 is a little bit more related to authentication, even though it's called unauthorized. All right. And to me, 403 is more about authorization. Note, and I love it that HTTP statuses, they just added this in the recent years because this wasn't there some years ago, a couple of years ago. A lot of websites don't report 403 forbidden. Forbidden means, bushing, right? It doesn't report 403. Instead, it says a lot of websites, a lot of APIs just say 404 because they don't want you to know whether your token is wrong or the resource doesn't exist because they don't want you to go around guessing resources. So it's up to you whether you want to use 404 or 403. All right. I like 403 because it's a little more clear, it's more direct. But if you're afraid that people are typing in random resources to try to get it, like you have some secret documents and people are typing in random ID numbers into the URL, then do 404 and they don't know whether the resource exists or doesn't exist or they're not authorized, okay? Great. So I think I've just about kept it in time. We're just about out of time in 3 minutes. Any last questions before we call it a wraps? So this is our introduction to authorization, and it's also showing you how we can use the concept of capability list, though it's not a real capability list. You got to remember that. The authorization token doesn't have within it some details about what you can and cannot do. It could. By the way, it could. You could totally make an auth token that has within it some information about what resources this person can and cannot get. Okay, but I'm not doing that yet. But I've just got the identity of the user in there for now. So, but in a way, it acts like a C list or a capability list in that I am simply holding on to information about who the user is and therefore what resources they can get by default. Okay. And the nice thing about it is for simple resources like show me all the projects of the user, you notice I did not have to write a single if loop. I didn't if statement. I didn't have to say if this user is the user that belongs to this project, like I didn't have to write any if statements. I will have to write if statements later for more complex authorization rules, which we call policies, and I'll talk about that in a future week. But for this week, when I don't really need any complicated logic, I can totally eliminate any conditional logic. I don't have to ask if this is the right user. No need. Give me the auth token. I'll get the username out of there. And I will only look at projects that belong to this user. Fine. If you're trying to get some other project, I can't find it for you because it doesn't belong to this user. If it doesn't belong to this user's list, okay? So there's a whole bunch of resources that you might be able to access with this kind of logic without having to write very complicated if statements. If there are resources for which you have to write some complex if then else logic, go ahead, do it, but I'll show you in a future week how to write that properly in a formal security policy. But for now, you can write some ad hoc if-else statements if you need it, okay? But we'll try to get rid of those ad hoc if-else statements because that's the stuff that'll let you down, okay, later. And it gets complex, okay? Cool. All right, thank you all very much. Thank you all for coming on time. I appreciate it. Bye-bye. I'm going to end the streaming first, so